Hey everyone, welcome back to my channel Tech with Megha, and I hope you all are doing well. So in today's video we're going to understand what are microservices and why do we even use microservices? What is the concept behind it? So before understanding what are microservices, we need to understand what are monolith. Like what is monolith, what is the concept behind it, and why what were the issues that microservices were trying to solve. Let us take an example of say Uber. And you know that Uber is a application that we all use. It's a kind of transportation application where you book the cab and you can travel from one location to the other. It's very easy. So let's see how things were there in Uber. So now with the example of Uber, let us try to understand how monolith architecture, or you can say the concept, works, right? Okay, so with the example of Uber, let us take the example of Uber and try to understand that. So we all know that Uber as is an application. So in Uber, there are plenty of features and functions available. So I have listed few of them to understand the concept of microservice. So let us say that there is a feature, or you can say a service, or you can call it function, where one of the services passengers web UI. This is where you actually try to book a cab, right? The where you get the search option, or you want to pick up where you want to enter the location and all. So this is one kind of service. And then we have one more service, or you can say one more function, like drivers. So this is where drivers can actually accept the booking and continue the next options. And then there is payment. So in the payments is where you can pay the amount or the bill that you need to pay to the drivers. Then let us take notification. So notification is a way where you get the information about your traveling time, or you can say it gives you the notification such as this is the time that you will be reaching the nearest location. And finally we have trip management. This gives us all the details about trip. There are plenty other services and features of Uber, but for this example we'll consider this five features. So now what happens is, if you talk about monolith concept or monolith architecture, in that particular architecture, the entire code, or you can say the entire component for all this functionality and services, will be written as a single unit. Okay, and this entire code for all these services will be developed as a single unit. So there will be developers who will be writing code for this, right? It's not like this particular service will be written separately, this particular driver service will be written separately. No, entire thing will be developed as a whole, as a single unit in monolith architecture. So the other point here is the code deployment. Okay, the code is deployed as an entire whole single unit. Say for example, if the developer made some changes or updates in the code for this payment services, then still you have to deploy the entire code, including passenger, drivers, notification, trip, entire services as a whole will be deployed. So indirectly you can think of it as the entire application. We write CI/CD pipeline, right? In perspective of DevOps, we write CI/CD pipeline to do the releases, build and releases. So in monolith architecture, the entire application will be having a single CI/CD pipeline. This also indirectly tells us that in monolith architecture, the application will be written in a single language. Say, for example, there is a requirement of, say, that developers are written the payment services in Python. So, all the remaining services should also be written in Python because it has a dependency, and we are developing it as a single unit, not like a separate. That is what monolith architecture requires. So, indirectly, this is making use of a single technology stack. So what are the issues that we face in monolith concept? Let's take the same example of Uber application. So while developing the application, there are plenty of teams who would be working on each of these services. Say team A is working on passenger service, team B is working on drivers, team C is working on payments, and so on. So in monolith application, it becomes very difficult for teams to collaborate with each other. The reason is, if team A wants to make a single change in the passenger service or passenger function or whatever is the feature of this Uber application, it becomes very difficult and the entire application needs to be deployed. Not only this, but the remaining applications or remaining services also needs to be deployed. So this becomes very difficult for team to work together, because each and every team have to make sure that their changes should not override the other team's service or other team changes. So in monolith, as I said, that entire code is been developed and deployed as a single unit, so it becomes very difficult for the team to collaborate with each other. Second issue that we face in monolith applications or monolith concept is that scaling individual services is difficult. So, say for example, that we know the developers know that this particular service, payment service, requires to be scaled up or scaled down. Then we need to scale each and every services in that. So what happens is, like, it's not possible, or you can say it's very difficult to scale a single individual application. But if you still want to scale that individual application, you need to scale the entire infrastructure, which will be resulting in a higher cost and a higher resource utilization, and there is less flexibility in the less flexibility in scaling as well as the team collaboration. Next issue that we face in monolith applications is version dependency. Say for example, this driver service is being developed on the version of 1.8 and payment is also 1.8. Later on, there was a requirement of changing the version from 1.8 to 2.1. So in monolith application, it becomes very difficult to make that change. As I said, that entire code has been developed as a single unit. So there is dependency on each other. One more major impact that occurs in monolith application is the release process. So we know that whenever there is a code change or we there is new feature update has been happening, we want to build it and test it, right? So the release process becomes very lengthy and time consuming also, because a small change, even a small change of a version change in any of the service would require not only deploying that particular service, but the entire service need to go through the entire release process of testing, building, deploying. So ideally what is happening, for even for a small change, the entire application is getting deployed. Now, in order to solve all these issues that we saw in monolith application, there came the existence of microservices. So, microservices helps the team to build a scalable application, and each of the microservices will be having their own database. These applications are actually loosely coupled. Loosely coupled means they are independent to each other. So now let's see how these microservices a concept actually works. Okay, so in the earlier example of Uber, we saw about the monolith. If Uber was working on monolith concept, now here you can see that each of these services are independent of each other and they are not tightly coupled with each other. So passenger becomes one service, driver becomes one service, payments become one service. So this is how indirectly what it means to say that we are breaking a big chunk of code into small chunks of code. You can think about it in that way. So entire code for these all the features or all the services were written in a single unit. Now that has got divided and acting as a single microservices. So one of the major benefit that we see in microservice concept is scaling. So scaling individual or scaling down individual services becomes very easy. Here we don't have to depend on the entire application to be scaled as we saw in monolith. Here if you want to scale up a particular service, then you can automatically and easily scale it without affecting the other services. One more benefit of using microservices is that team collaboration. So earlier we saw that if a team or team A or team B wants to make any changes in any one of the service, they have to be very sure that they are not updating, or they are not making changes in the other services where other teams are working. Now, since we have broken down all these services into individual and they are working independently, team collaboration becomes easy. So if team wants to make any change in the payment service, they can easily do it. They can update the versions, they can update the code, they can make the changes as per the requirement, and team collaboration becomes very easy, and teams can focus more on the services or whatever code they are working. Indirectly, this is also increasing the efficiency. Then we have one more benefit is deployment strategies. So deployment that we saw in monolith application was that any small change requires the entire application to be deployed. Now that is not the scenario. Now if you make any change in one of the applications, a driver, you can deploy it, you can build it, and if you come across any kind of issues, you can still redeploy it without affecting the other services that are simultaneously running in the applications. Okay. And dependency, as we saw in monolith example, that if there is a dependency update to be done in driver service, say from version 2.1 to 2.2 or 4, whatever is the version, it became difficult in monolith. Now here, since there is no dependency, you can easily make the you can easily make the changes and deploy the code also. So dependency that we had in monolith got removed here. So microservice is a concept that is basically much more adapted in bigger organizations, you know. So if it is a very small organization, dividing your code into microservices and all becomes little bit difficult. But if it's a very big organization where you are having a lot of teams working and lot of functions and services you are developing, say for example, as I gave the example of Uber, there is one more big company, that is Netflix. There are plenty of features every week they are releasing, and we don't know how much kind of changes are taking place in those kind of scenarios. In those organization, microservices concept will play a major role in their efficiency increase as well as saving the time. So now you must be thinking how these microservices communicate with each other. So one of the common way for microservice communication is using the API calls. Okay, so these microservices, say for example, if microservice passenger wants to communicate or interact with the microservices which is named as drivers web UI, then it will make use of API calls. Ideally, each of these microservices that we saw here, each of these microservices will have their own individual API and API endpoints. So what happens is, if I want that microservice passenger wants to communicate with this will actually send a standard HTTP request to microservice, and then it will respond in the same way using the HTTP request. Now, uh, this is the way how communication happens using the API calls. Now, what are the types of communication that microservices makes use of? So one of the common example is synchronous communication. Okay, synchronous communication is the way where a standard HTTP request is sent from one service to the another microservice when they want to interact with each other. There is one more communication way that happens in microservices, that is called as asynchronous communication. Now in asynchronous communication, what happens, there is a message broker. Some of the examples of message broker are like Apache Kafka. So what happens is, here, if the microservice that is named as passenger wants to communicate or interact with the other microservice, it will send its request or send its message to the message broker. Now message broker will actually direct the message from this particular service to the respective service where it needs to communicate, and vice versa, it communicates and gives the information. So this is called as asynchronous communication. There is one more way of communicating is using the service mesh, that is the Istio in Kubernetes. If you are using microservices in Kubernetes, there is Istio is one of the like you can say example of having the communication done. Thank you for watching my video, and if you like my video and if you want to see more videos based on DevOps, please do subscribe my channel and do like, share and comment. Thank you.